Hello, friends. Welcome to another important topic on AI. Today, we are going to talk about AI architecture best practices. So, friends, AI is no longer an experiment in the enterprise, it is a decision making system. Today, AI influences credit approvals, hiring decisions, customer interactions, and operational actions. And when system starts making decisions at scale, governance is no longer optional, it becomes essential, isn't it? Most organizations don't struggle with AI because of technology, but they struggle because they deploy AI without defining ownerships, defining adequate controls, or life cycle accountability. AI scales faster than any previous technology, but without governance, it also scales risks, bias, and regulatory exposure. AI governance is not about slowing innovation, it is about making innovation sustainable. Organizations that govern AI well will scale faster, fail safer, and earn trust from the regulators, customers, and boards. In this video, I will explain how enterprise AI architecture combined with lifecycle governance and MLOps ensures that AI remains scalable, trustworthy, and under control, not just innovative, but also responsible.
In this slide, we are going to look at various architecture layers of AI. At the top, business and governance define the purpose of AI, the organization's risk appetite, and most importantly, clear ownership. AI should never exist without accountability. Below that, the data layer ensures models are trained and run on trusted quality control data with proper lineage and access controls. The AI and machine learning platform is where models are built, tested, and validated before they ever reach production. Finally, decisions. Decisions are not made by models alone. The decisions layer deliberately combines AI outputs with business rules and human oversight, ensuring responsible use. In the next layer, MLOps then governs the entire lifecycle from training and deployment through monitoring, improvement, and eventual retirement. And finally, monitoring, security, and auditability cut across every layer, ensuring AI remains transparent, controllable, and compliant throughout its lifecycle. This slide describes 6 core AI capabilities. Generation, let's look at generation, where AI generates new artifacts such as content, code, or documentation. Stewardship focuses on improving quality and relevance of existing data and knowledge. Interpretation is the capability which helps us navigate existing content through summarization, translation, and restructuring. Insight provides useful information about patterns, anomalies, and trends. Interaction positions AI as a natural interface between users and services, enhancing service desk capability greatly and user experiences as well. Finally, orchestration is where AI triggers or orchestrate action across systems. This capability must be tightly governed as it poses certain varying amount of risks. This is an interesting slide. This slide represents risk heat map showing how different AI risks manifest across the 6 core AI capabilities. What's important here is not any single cell but the overall pattern. As we move from generation and stewardship on the left to orchestration on the right, AI capabilities become progressively more autonomous and operationally impactful, and the risk profile increases accordingly. Lower risk areas shown in green are typically associated with content generation and data handling, where outputs can be reviewed and corrected before use. As we move into yellow and red zones, particularly in insight, interaction, and orchestration, AI begins to influence decisions, interact directly with users, or trigger actions across systems. These are the areas where risk related to transparency, bias, data misuse, regulatory compliance, operational impact becomes significantly higher. The key takeaway here is the governance must be capability aware. Not all AI systems require same level of control. But as autonomy and impact increases, stronger oversight, approval gates, monitoring, and human in the loop controls become essential. A very common mistake organizations make is starting AI initiatives with models and tools instead of looking at what business benefit it is going to give. Best practice is to start with business and governance architecture first. AI should be treated as a business capability, not as a technology experiment. That means AI architecture must be anchored to clear business outcomes, such as efficiency benefits, risk reduction benefits, revenue growth, or regulatory compliance. It should not be looked at just another technical performance or experiment. Equally important is defining decision rights and accountability in business and IT domain. Every AI use case must be mapped to business process with clarity on what decisions are automated, which remain human led, and where hybrid decision making applies. Finally, organizations must explicitly define their risk appetite for automated decisions. This is very important. Without these governance foundations, scaling AI simply means scaling uncertainty and risks. The second best practice is adopting a layered AI architecture based on separation of concerns. The objective is to avoid tight coupling, vendor lock in, and uncontrolled decision making. In well designed AI architecture, data, models, and business logic are independently replaceable. This gives organizations flexibility, resilience, and stronger governance. At the foundation is the data layer, which focuses on data quality, lineage, privacy, and access controls. Above that is the AI and machine learning layer, where models are trained, tested, and versioned without embedding business rules. The interface and decision layer is critical. This is where AI outputs are combined with business rules and where required human approvals. Next is the application and integration layer, which embeds AI driven decisions into business workflows and systems. Finally, monitoring and governance cut across all layers, ensuring security, auditability, compliance, and ongoing performance oversight. A key lesson from enterprise AI program is that data architecture matters more than model choices. Even the most advanced AI models will fail if the underlying data is poor, fragmented, or ungoverned. Data quality, consistency, lineage, and timeliness directly determine the accuracy and trustworthiness of AI outcomes. So it is very important to pay attention to this. From a governance perspective, data must be traceable, secure, and compliant, especially when AI is used for automated or high impact decisions. Strong data architecture ensures controlled data sourcing, proper classification, and clear ownership. When the data foundations are right, models become interchangeable. But when data foundations are weak, no models can compensate. To scale AI safely and sustainably, MLOps must be treated as a core architecture capability, similar like DevOps. It is a best practice to manage AI models exactly like production of software assets, where tools and processes together are used to deploy assets into production environments. This means formal versioning of data, features, and models, along with automated pipelines that take model from training through testing and into control deployment. Equally important are rollback and retirement processes because models degrade over time and must be actively managed. From governance perspective, MLOps introduces approval gates similar to ITIL change management processes. It ensures full auditability, including who trained the model, on which data, and with what parameters, making AI decisions explainable, controllable, and defensible. A key principle of responsible AI architecture is designing the role of humans explicitly into the decision lifecycle. Not every AI decision should be fully automated. The appropriate level of human involvement depends on business risk and impact. For example, advisory decisions such as risk scoring, AI provides insights, but final approval remains with human beings. In assisted decisions, AI recommendations are combined with business rules, supporting faster and more consistent outcomes while retaining oversight. Fully automated decisions such as chatbots or routing are appropriate only where risk is low and must always be backed by strong monitoring and clear fallback mechanisms. By designing human in loop deliberately, organizations balance speed, control, accountability, and trust.
Remember, organization must be able to explain the outcomes generated by AI solutions. So explainability must be designed into AI solutions from day one. It cannot be added as an afterthought. From a governance perspective, organizations must be able to explain not just what AI decided, but why it made that decision. This is achieved through practical mechanisms such as model interpretability tools, detailed decision logs that capture inputs, outputs, and confidence levels, and clear reason codes that can be reviewed by users, auditors, and regulators. Explainability is not optional, it is essential for regulated environment such as financial services, healthcare, and the public sector. And it is foundational requirement under emerging regulations like the EU AI Act. Another important aspect is AI security cannot be treated as separate from enterprise security. It must extend traditional security architecture to address AI specific risks. In practice, this means protecting the entire AI lifecycle, starting with controls against data poisoning to ensure training and inference data cannot be maliciously manipulated. Models themselves must be protected through strong access controls, while generative AI solutions require safeguard against prompt injections and abuse. Inference services should always be exposed through secure API gateways to enforce authentication, authorization, and rate limiting. Finally, zero trust principle equally apply here to AI models. AI models must not automatically trust data sources, and every inference request must be explicitly authenticated and authorized. This way, you can ensure security of AI solutions. When using large language models or generative AI in the enterprise, architecture choices are critical for governance and control. Rather than fine tuning models with proprietary data, best practice is to use retrieval augmented generation or RAG. So enterprise knowledge remains in governed data stores and can be updated without retraining models. Another point is prompt templates should be treated as configuration artifacts and kept under version control, just like codes. Next point is strong guardrails are essential, including content filtering, hallucination detection, and output validation to prevent unsafe or unreliable responses. And a critical governance rule: large language models should never be used as systems of records. Authoritative data must always reside in enterprise system, not in AI outputs. Critical best practice in enterprise AI architecture is to build for change, not for perfection. We must assume from day one that models will degrade over time, data patterns will evolve, and regulatory requirements will continue to tighten. Because of this, AI must be designed to adapt safely, not to remain static. Architecturally, this means using modular services so components can be replaced without disrupting the whole system. Importantly, adopting cloud agnostic components where it makes sense to avoid lock in, and enforcing contract based APIs to protect downstream services from change are essential controls. This approach ensures AI platforms remains resilient, governable, and compliant as both the business and regulatory landscape evolve. Key best practice for governing AI at scale is to define KPIs at multiple levels, not just technical metrics. At the business levels, AI must be measured and on outcomes, what business benefits it has delivered. For example, you can measure improvements in the efficiency, cost reduction, risk mitigation for the organization, and compliance performance. At the technical level, team track model accuracy, response latency, and data or model drift to ensure reliability in production. And critically, at the governance level, organizations must monitor indicators such as bias incidents, human override rates, and audit findings. Together, these KPIs ensure AI systems are not only effective but also trustworthy, compliant, and aligned with business objectives. To conclude, a good enterprise AI architecture can be validated using a simple checklist. First, the business use case must be clearly defined. AI should always solve real business problems, isn't it? Second, data ownership and quality controls must be in place to ensure trust in outcomes. Third is the architecture should be modular and layered, allowing components to evolve independently. Next is MLOps must be integrated with IT service management to control changes, releases, and incidents. Next is human oversight should be intentionally designed into decision flows, not added later. Next is explainability and audit logs must be available to support transparency and compliance. Importantly, security and privacy must be built in by design. And finally, continuous monitoring and improvement should be implemented to ensure that AI systems remain effective and compliant over time. UBIT is a globally recognized framework for governance and management of enterprise IT. This framework is developed and maintained by ISACA. The recommended best practices explained in this video directly maps to the AI specific COVID controls. To conclude, enterprise AI success is not about developing the most advanced models. It is about designing architectures that can be trusted, governed, and scaled responsibly. When AI is built with clear accountability, human oversight, explainability, and lifecycle controls, it becomes a strategic asset rather than a risk. The organizations that will lead are those that treat AI not as a tool but as a service, which is governed, measured, and continuously improved. In the end, good AI architecture is good governance by design, isn't it? Friends, in the upcoming videos, I will discuss various failure modes in AI and how to avoid them. And we will also talk about ML ops. Let me know in the comments box if you are interested in knowing about other topics related to IT governance and management. Like and subscribe this video if you are interested in these topics. Thank you.